welcome everyone to our live event, Let's Talk Electrification. We're thrilled to have you with us today as we delve into the fascinating world of electrification. We stand on the brink of a major shift towards hybrid and all-electric mobile machines, a transition that brings with it a myriad of complex challenges. But fear not, because today our experts are ready to guide us through this transition. They will be sharing their insights and discussing the challenges that electrification presents. So whether you are an industry professional, a tech enthusiast, or simply curious about the future of mobile machines, this event promises to be enlightening. Join us as we embark on this journey of discovery and innovation in the kingdom of electrification. My name is Pernilla Nimmermark, and I work as a Marcom leader in the Nordic countries, and I will be your host today. Before we start, I have some practical things. This full event will be recorded, as well as all the breakout sessions. Everything will be made available to you after the event. During the whole event, you will be on mute, and questions can be placed in the window below the agenda. If you have any comments or something that you would like to share with the rest of the audience, please use the chat. Soon, I will introduce the keynote speaker, but prior to that, I will run you through today's agenda. Shawn Horner, Vice President of Technology and Innovation at Motion Systems Group at Parker, will give you an overarching insight into electrification. Next, Nils Henriksson will talk about digitalization and electrification design challenges, followed by a panel discussion about Parker as a partner in electrification. Then there will be two rounds of breakout sessions with a short break in between. After the last round of breakouts, Tom Kühne from Stream Propulsion will give his testimonial about the transformation to electric drive of the leisure boat business. And finally, there will be a panel discussion about future challenges in the mobile electrification. As we have a packed agenda, let's start talking electrification. How do you increase productivity at the same time as you eliminate or downsize the combustion engine? Our next speaker, Shawn Horner, Vice President of Technology and Innovations at Motion Systems Group, has been deeply involved in multiple electrification journeys, and I promise that his insights are both enlightening and inspiring. A warm welcome to Shawn from Parker's headquarters in Cleveland, Ohio. Shawn, good morning.
Pernilla, good afternoon, and thank you for having me.
Thank you.
What a great opportunity.
Yeah, thank you. So I will hand over the floor to you. So we are looking forward to hearing from your presentation.
Thank you, and a warm welcome to everyone joining us online from wherever you are in the world. So without further ado, let's get started. So, as we can see here from my bio, I've been with Parker 14 years. I've worked in a variety of our operating groups and in a variety of functions. I'm really most excited. Probably the best part of my career has been the last couple of years where I was leading our Motion Technology Center. We'll speak more about that here in a bit. Really focused on helping our customers through this electrification transition and journey. And in addition to me today, you're going to hear from a number of my colleagues at Parker and also one of our customers around how we're collectively partnering to navigate this journey together. Well, I'll give you a brief introduction on Parker for those of you who are not familiar with who we are as a global corporation. We'll speak about the electrification journey, both our journey and our customers' journey. We'll talk about the common customer issues that we see along the way, and of course, why we think that we make a fantastic partner for the industry and for all of you. So if you may not be aware, Parker is quite a large global corporation, approaching about 20 billion in sales, over 60,000 employees around the world. And we're 100% focused on motion and control. I think that's what distinguishes us a bit from other very large corporations or in the industrial space, is that all we do is motion and control. And you'll see later, really, we have, in my opinion, the best breadth and depth of technologies that are interrelated around motion and control. And that's going to be a key part of my message here for everyone this morning. We have a very strong network of global independent distribution partners, and distribution partners come in many flavors, but specifically around electrification, we have a number of very strong integration partners who we partner with and can then partner with you as well in terms of helping you navigate this journey and conversion from the internal combustion engine to a more electric future. Our decentralized operating structure allows us to be both large but also locally responsive and nimble. And that's also a key aspect of why partner with Parker. As a corporation, we look at 5 really mega themes for secular growth. You can see them here: aerospace, digital, electrification, clean technologies, and what we call mega CapEx projects, or large infrastructure investments. I think what's really important to understand here is, while these are all 5 separate themes, they all have a common thread of technology running through all of them. And we'll talk a little bit about that. And I know some of my colleagues later will speak to it. But really the types of R&D investments, as well as the skills needed to be successful across all of these, has a very similar set of characteristics. Across Parker, we speak about these technology platforms. You can see, again, it's quite diverse in terms of technologies and end markets, but again, it's very interconnected. So you can see, first and foremost, our customers value that interconnected ability to bring not just component level, but system level solutions. 2/3 of the overall revenue of Parker, of that 20 billion, comes from customers who buy from more than just one technology and typically buy from 4 or more. So you can see that's quite a large vote of confidence from our customers about the value of our interconnected portfolio. But I think for this audience, what is perhaps most relevant is that, as we look at our technology portfolio at a level deeper than this, 2/3 of that portfolio really helps enable clean technologies. It does it through a variety of ways, but I would highlight a few. Number one, we're always focused on improving system level efficiency. Starts at the component level, but then how do we maximize integration, leverage our application engineering expertise to really help our customers increase their system level efficiency. Perhaps the number one challenge as we move from the internal combustion engine to battery powered or hybrid powered vehicles is, how do you get runtime? And therefore, the efficiency of all the components in your system is really critical. We do that in a variety of ways, but a couple of them would be by reducing the weight of components, by creating more compact, more energy dense systems. Another way is by improving the thermal management of the systems. And we have a variety of technologies that address that, one of which you'll hear about today as well. In terms of organizational structure, I talked about our decentralized operating structure, which again does allow us to have engineering and operations footprint all over the world, close to our customers, being able to be locally responsive. But a few years ago, as we really started to see that the tipping point for electrification, particularly in off-road, we really started to think differently about our organizational structure and how we were organized around R&D specifically. And so the 2 boxes, on the one on the far left and the one on the far right, have been a part of Parker's DNA for a little bit longer. But the one in the middle, the Motion Technology Center, we really stood up in the 2019. So coming up on really 5-year anniversary of creating the team. And we really built this center and team to be 100% focused on electrification. We built it to help bridge the interconnected piece between our aerospace engineering and our industrial engineering. Our aerospace engineering has really lived in a more electric future for a long time. Now, that said, we can't just take a cookie cutter approach to taking what we do in aerospace and putting it into industrial. First and foremost, a lot of the solutions would be far too expensive, but we certainly can take the lessons learned, a lot of the foundational knowledge, translate that, and then make it work in our industrial space, and in this case, the off-road space. So the first reason to do it was to be able to leverage that strength. The second reason to do it was really to build a center of excellence where we could really hire some of the best talent in the world. And particularly as we think about new skills required to be successful. I would point out, a power electronics skill set and depth, as well as software and controls expertise. And so we've done that. And then third, it's really about then, taking the technologies that are developed in a place like the Motion Technology Center and deploying them into our operating divisions. That then ensures ownership and, again, that local touch, feel, and responsiveness to our customers. So I'll shift a little bit. It's a little bit of how our electrification journey and how we've organized ourselves to be successful. I want to talk a little bit about our customers' journeys. And no one customer is exactly alike, but I would say having spent time with customers across every variety of our market segments in the off-road space and the on-road work vehicle space, I think these themes really do resonate across the whole space. The first one is today, I would say the vast majority of our customers are still in this first box, this first phase, a conversion of existing machines. We look at it as a bit more of a retrofit. Take the internal combustion engine off, put a battery pack in there, and then really with a heavy focus on the powertrain, right? Of course, that's where they'll get the most efficiency benefit. That's where the most carbon benefit comes from, by removing the internal combustion engine. We talk a lot in Parker about kind of that propulsion function versus the work function, the work that machine is going to do through actuation solutions typically. And in this first phase that we see work functions are largely unchanged. Specifically, if we're speaking hydraulics, a lot of customers aren't changing a thing about the hydraulic circuit. What we do have to do is ensure the integration between what now is an electrical power source versus a diesel-powered mechanical shaft power source works. So we talk a lot about making sure we've got good inverters, motor controllers, electric motors to then drive our hydraulic pumps, and the integration of that system and ensuring that system is paired well, that we are getting the maximum efficiency out of that system is critical. So that's what we speak about. Electro-hydraulic integration is really important for our customers in this space. As we move to the right, I use the term constrained optimization. Here, this is where we start to see, I would say, where customers start to see volumes on specific machines increasing in terms of adoption rate. Then they can spend more of their engineering time and focus on ensuring that they're optimizing that machine for efficiency to get the runtime to enable the productivity levels for their customers. This typically then requires a deeper look at the subsystem levels, including the work function systems and the hydraulic actuation systems. And we certainly have many technology approaches in our portfolio, some of which you'll hear about today, that lend themselves to certainly improving optimization of efficiency as that becomes a more critical performance factor than perhaps it has been in the past. Is also the trend towards more digitally actuated solutions, more digital control in these vehicles. But the reason I say constrained optimization is they're really, for the most part, not touching the metal, structurally similar. And the reason that is really important is because for the most part, our customers want to be able to produce this equipment on the same lines that they produce their current models today. Right. So can you produce an internal combustion engine based machine and an electric, whether it's full electric or hybrid, on the same manufacturing line is really important. As we're again in this still kind of transitioning. This would be a transition from sort of early adopter, into sort of the beginnings of volume type of production. So that's a really important phase. And I'd suggest, we're definitely in these first two phases today across the industry, probably more heavily in the first phase. Some customers and in some of their machines are in the second phase. Really no one today, at least not in any volume approach, is really on the far right. And so, I think as we look forward, and the exciting thing is, we're starting to work on these things today because we can't wait until it's time to make this conversion to have the R&D and then the technology ready. But we can really be much more creative if we can think about with our customers as our customers start to think about clean sheet machine designs, it really opens up a whole world of possibilities. We're now less constrained in terms of the envelopes we have to work in terms of our actuation solutions. We can certainly become much more digital and connected. This is where the topic of autonomy becomes really very important and interesting, is that you can think very differently about the form of a work machine if you don't have to have a cab, right? So those are the types of things that we're working with some of our customers on today. And again, it really allows us to think very differently and more novel about work function system design. But for the most part, this is still very early R&D work. Most of our customers, again, are not in this phase in terms of looking to serial production anytime in the next few years in terms of this type of work. So you sort of hit on these already. If you really boil it down, you've got a couple of important challenges for, I think, our customers. And again, I would say these are sort of generic, but I think they span the breadth of what all of our customers are facing, which is they have a lot of machines to convert, right? I mean, our customers have built the portfolio of their products over many decades. We built, again, our portfolio of components and systems that support those machines over many decades, and conversion's hard. It's in some cases, it's not even that technically that it's that challenging. It's just a lot of activation energy to put into the system, particularly from the engineering and the operations and supply chain teams. So, and really balancing what's commercially viable today versus what are important technology demonstrators to be able to seed the market and get their customers excited about the potential of the future. So that really comes down to balancing resources. I think we see today, actually a pretty good example is in the passenger car market, where we see, really, the need for all the automotive OEMs to really balance their portfolios. Those who maybe have tried to go all the way into electric vehicles. I mean, certainly Tesla's a unique case, but, all the others who are, have to really balance how far do they push without abandoning their existing platforms and continuing to refresh and making them relevant. I think we'll be in a mixed model world for any number of years. I mean, I don't believe anybody can predict today when we'll hit the big tip over of the transition. We certainly know in the 2030 timeframe, we see a lot more regulation coming in. But that said, I don't think the internal combustion engine is completely disappearing immediately. So our customers have to balance between, and we have to balance our support between how we help them continue to drive improvement of their current platforms while making this transition. The last point, and maybe perhaps the most important point, is there's also the new skills required to be successful in a more electric world. I've spoken already about software and controls engineering, electrical, particularly power electronics engineering. The last, functional safety, and I really would add to this also cybersecurity. So, and the thing within, all of these areas is that it's not just having the engineering, understanding, it's also having the systems and the processes and the organization behind them to be able to execute in a way that will allow us to flow down functional requirements, certify systems that didn't have to be certified in the past through third-party organizations. And do that in a way that's highly disciplined and structured. We actually have quite a bit of experience with that coming from our aerospace side of the business. It's not, again, one-to-one, but it really helps us lay out a blueprint of how to do that well. And again, I think that's something that our customers value in partnership with us, is that they can leverage some of that background and experience as well. So, why partner with Parker? Hopefully I've given you a sense of this already. I think when we look at ourselves, we look with our customers, we bring not just depth, but breadth in this domain. As I said, all we do is motion and control. And it's not just at the component level, it's at the system level. You'll hear from my colleagues later about, again, how we've been able to partner with customers on retrofitting of equipment and looking really at the full application engineering and ensuring that we're really helping them really optimize the system, not just pick the best motor or the best pump. Global footprint. Few companies can match what we have in terms of our footprint in the region, in terms of not just operations but engineering in the region, and being able to leverage that scale though, so that so we believe we sort of have the best of both worlds here. And lastly, long-term commitment. Parker is a 107-year-old company, and we're a very financially strong company, so we're not going anywhere. So in closing, we're ready to partner with you to de-risk your electrification journey. And I know that my colleagues look forward to sharing with all of you some more of the technical details around how we do that. So with that, I'll turn it back to you, Pernilla.
Thank you so much, Shawn. You really set the scene for today. However, during your presentation, I received a couple of questions from the audience. So firstly, what makes Parker a trusted partner in my electrification journey, and why is Parker better than anyone else?
It's like they read my presentation beforehand. I think first, as I said, I really truly believe it's our depth and our breadth. We have been partnered with our customers around work machines for a very long time. We understand the duty cycles. We understand what in our portfolio, how to make the best selection of, again, a motor and a pump and an actuator and a control system to be able to have the machine do what it needs to do at its highest level of productivity, and also at a highest level of efficiency that it's really required in a more electric world. Two, as I said, I think our global footprint sets us apart from many of our competitors. And then third, I think that long-term stability, electrification, this journey isn't a journey that it's a marathon, it's not a sprint. So you really want a partner that's going to be there with you for the long term. Okay, thank you. And next, from your perspective, what are the main challenges in an OEM's electrification journey? To me, I think right here from all of our customers is it's just a lot to do. I think there are some technical challenges, and we're certainly extremely pleased when we can partner with our customers to help them solve the technical aspect of the challenges. But some of it is just there's too much for any one team to handle by themselves. Again, between how do you balance the R&D on new machines while maintaining the freshness of your existing portfolio. So I think in a world where a lot of our customers, but on the OEM machine builder side, have done a lot of things themselves in terms of internal engineering over the years, now find themselves in a place where it really requires partnership on their part, so that people like us and others, but certainly we're here talking about us, are able to help them really supplement what they're doing in their engineering teams. And I think you'll hear some really good examples of that here coming up, I think, right after me. True. Thank you so much for joining us today, Shawn. I wish you a lovely day ahead. Thank you, Pernilla, and thank you to everyone on the conference. And I hope you all take away one or two really important things from this. And we look forward to working with all of you and advancing this journey together. Thank you. Thank you. Okay, so now we're shifting gears a little bit. So we are going to involve you in the audience and ask you a poll question. Are you working with electrification within your company? And you have three alternatives showing up on the screen. Yes, we are at the beginning of our journey. Yes, for several years. And no, we haven't started our journey yet. So you can see the alternatives in the window in the left corner below the agenda, and click on the alternative that suits you the best, and you submit your answer by clicking on Send. While you are answering the question, I would like to introduce Ari Vuoronen, Group Sales Leader.
Thank you, Pernilla.
Yeah. So what are your expectations for today?
I think building on what Shawn just said, we will be seeing today very much about the component and system advancement, but also building on the resources, knowledge need. And then I know that there is a good expectation to hear a lot about what the markets are looking for.
Yeah, And what do you think the main takeaways will be?
I hope that our listeners will be hearing some critical success factors for the electrification journey.
Yeah, I'm sure of that. So let's look into the results from the poll. So we can see, let's see what we had for alternatives. 23% are at the beginning of the journey, 73% has been on their electrification journey for several years. What are your comments on that, Ari?
Well, I think that kind of reflects also the situation that we see. There is a lot of activity on the electrification, and obviously customers are not in the same phase. Some are progressing further, some are making early steps. Maybe a little bit surprising if no one is not yet in the beginning, but this is anyhow for everybody, I think, this event.
Yeah, good, thank you. Moving on. We all know that mobile machinery has developed to meet new requirements to minimize emissions, improve productivity, and optimize system solutions. How do we utilize electromechanical, electronics, and hydraulics to define the best mobile system solutions? Our next speaker, Nils Henriksson, has more than 35 years of experience in the mobile industry and off-road applications and machinery. He spends his days focusing on business development and system engineering. So I would like to hand over to Nils Henriksson, EMEA Mobile Center of Excellence Manager.
Thank you, Pernilla, and good afternoon, everyone. Yeah, I spent the last 15 years just on electrification, but before that, as Pernilla said, some years also on pure system engineering side. But I would like to take you back a little bit. I would like to talk about today's sustainability, but I think the trend really changes. It was a milestone here in the end of 2015, beginning of 2016. Where it changes to go from what we would say fuel cost drivers when we did machine solutions based on load sense applications and so forth, from going in to be more emission based. And I think that have actually changed the driver and the incentive really to make a different system. And you can see we have all working on different type of solutions of what is needed for different engines. And you can see in the slide here that we have multiple requirements on emissions from combustion engines. And that differences was really about the different regions as well. So we are used to produce a machine, going to different regions with different solutions. And I think that flexibility and modularity, it's still the same thing when we start to talk about electrification. So today we talk about to make it a really fast introduction that can be using biofuel or something like that when you can using the correct the diesel engine what we are used to today. But also we will see electrified machines will coming over more and more and become really important part. And also other cells, what we will have for fuel cells, for example, instead of batteries and so on, will also be a big challenge for us to have the modularity to really go in and see how we can serve our end customer. So by that, I mean, we are used to now talk about the electrification, and that journey have really starts. We just talked about the beginning, that was with the combustion engine controlling a valve on the implement side and then the motion on the system. We talked about hybrid solutions, what can be a very, very good option, especially when you're off the grid and you need to reduce the incoming power. And also pure electric, depending where the machine is operating, that's where a pure electric machine can be done. But whatever we do, all three of them, the importance of efficiency is a key factor for the future system designs. And how do we work with that? I would say number one is actually have pretty much control of all the losses in the system. And you can see here, by starting to recording how a machine operates is a key factor. to really understand where we would like to have the impact on the system design. So just have a big variety of monitoring all the energy coming into the system and everything what actually are used out on the cylinder side from a motion standpoint. So doing that breakdown and analyze where it will go, you can then see where you can attack the system, where is the losses, what is the difference you can make in the circuitry to gaining efficiency. And we have been used to working on what we will call electric hydraulic pump. That means we have replaced the PTO from a diesel engine by an electrical motor. We can spin the pump differently depending on what type of pump you have and what type of valve circuitry you have as well. So that is a key point. And that will have a way much more of power on demand capabilities compared to what we are used to with a combustion engine. You also have what we would call the electrohydrostatic activation, where you actually have, of course, power on demand, but you also enable energy recovery just because you can spin the pump backwards as well with a 4-quadrant operation. And then, of course, we can't achieve all in the same manner. So all the different functions probably have different ratio of capabilities for energy recovery and so forth. And that makes us a big difference compared to where is worth to spending the technology to gaining that in energy efficiency. So in reality, maybe a mix between the two would be more a reality compared to just choosing one option for all the functions. So what is the component what we're talking about? And I would say Parker now have introduced the new type generation of mobile products in the electromechanical space. And you can see here we will talk about the next generation inverters, what actually are designed for the mobile market. And of course, they have all the safety features, what is needed. But I will also say that it's not only designed for spinning a motor, it's also designed to be able to act how the hydraulic solutions will look like and require for the future. And if we're then taking the electrical motor, what we will say it's called the GVM. Of course, it's a really high efficient and compact unit. And the reason for it, it's really the high performance on the cooling capabilities. And again, it's very dynamic, so we can use that motor together with the inverter to get a very, very high performance on the hydraulic side. So that is the electromechanical piece, what is the key element. But I will also say in all of the electromechanical solutions, what we have been doing a system for, that's really about the interaction between digitalization as well, or the controlling capabilities. So we talked about energy efficiency on the electromechanical side. Equally important is to see what can we do on the implement side and the mobile valve side. So here you can see that we now introduce the next generation of directional valve, where we also include in our onboard electronics, what will give us so much more benefit, what we have not had before, that we have smart functionality and so forth. So you can see when we're moving forward, the smart connection piece of a valve give us, of course, traceability, so we know how the setting have been done, when it have been produced, and all that. We give you also connection via the CAN bus setup, and that give us more diagnostics and all of the interaction you need for having when you're doing more advanced controls. But you also have the smart functionality, and this smart functionality also introduce more about what we can also gaining in efficiency as well. So you can see here, it is a next generation valve, including also in combination how you utilize the inverters together with the electrical motor. So this is an example on how efficient the next generation valve are. And you can see here, we are utilizing what we will call the traditional mobile directional load sense valve. That is what you see in the bar graphs here, what is named K170. And we also have the next generation of directional valve when we have individual metering. And you can see here, it's named IMHC. And this is a significant efficiency gain. You can see on the energy side, we're actually reducing 8%. But even more important, that's really about the pressure getting down. And I think that is an area what we can really gain way much more if we think about how we can do the circuitry in the future. But the most important, it's actually the productivity. The productivity are maintained. So we have a lot of technology going into, when we talk about electrification, it also going hand in hand with the hydraulic side. Continue now with the mobile pumps. Of course, we have a variety of different technologies, but from a digitalization standpoint, it's now also been able to controlling this displacement by a solenoid. And that means we can actually gain where we can have the most efficient scenarios, solutions, and during the work cycle. That means the control system will play a more and more significant role in the digitalization. So of course, we're talking about now model-based design. It's a key element for it. We need to have all the sensors when it's needed to actually set up the system in the way we like to have it to work. And also, at least also the functional safety will become more and more important when we're actually doing the functionality of it. And the reason for it here in Europe, we have the machine directive. It's a massive picture, I understand, but we have the A series or A standards, we have the B standard. Importantly is the C standard. And the C standard is important because that's where all the bits and pieces are designed to achieve the performance levels what each of the functionality need to fulfill for the European market. And again, going back to the other parts, what we just heard before, that is the performance level, but also this cybersecurity area as well. That gives us the discipline. All of us love to do the software, so fun, but when you start to talk about functional safety, it's equally fun, but I would say we need to have the discipline. We need to have the discipline to work in the V model setup. That means we need to achieve the spec in the beginning, and what is the key parameter to be able to validate before we go into just start to do the coding. And then it going back on the other side to validate and verify so the code have been correct. And that discipline is very important for the future. Still, when we're starting to talk about to increase productivity, it's also the automation on the machine. By using this model-based coding, you can see in this example, it's actually on the forestry crane, you can see we're using now, instead of controlling each cylinder individual, we're doing a tip control. And that software piece is actually done in the Simulink environment and downloaded directly into the controllers. And you can see here, that type of simulation are available when it's coming into the machine to actually speeding up your design cycle. So historically, we have been used to talking about the pumps, the valves, and so forth. And the driver has actually been the key element of controlling. In the future, the driver will not have the power enough to actually have that experience and not be too tired. So you can see here, when we talk about a new design, we're going from a coupled design to a decoupled design. What gives us a lot of new capabilities? We are really used to designing a system based on the peak power, but in the future, we need to be able to design it on the average. So that means we can overtorque the electrical motor for some time and cool it down when we can rest. So the thermal management would be key element for it. And in the same talking from a control standpoint, it's not the throttle command from the right foot what is the key element. It's control to find an opportunity over the whole work cycle. So I would say that the key element on configured e-pumps, it's actually to be able to control it all over the continuous power, but also in the field weakening area, to have the same hydraulic performance. So the control algorithms become key. What we do on the controlling, by controlling the spinning the pump in different way, depends on the hydraulic solution. Still, to utilize the spin of the electrical motor to a fixed displacement pump, make us the opportunity to really do electrical load sense. So, by that, I will say the building parts, what we can provide for you as a partner, you can see that we have already electrical motors in place, we have the inverters in place, we have the control system in place, and also the hydraulic valves, what we just talked about, and the variety of the different hydraulic pumps. And as we said, and you will hear it more this afternoon, that is the thermal management, what become a key element really to optimize the sizing on the electrical component. And in the end, when we do this option or system solution A, B, and C, 1, 2, 3, and 4, it always include how much investment would you like to do on the hydraulic side, electromechanical side, together with the battery storage sizes. So the business case is about remove the energy as much you can do on the hydraulic and the electromechanical side, make smart control algorithms, and you can optimize your battery size according to your work cycle. And I would like to say that in the end, we are spending so much time into building these building blocks with proof of concept capabilities. We have the component, what have been integrated, all these features, what we have today. And in the end, it's really about shortened time to market. So if we can help you, please contact Parker. We will be more than happy to help you with. Thank you.
Thank you so much, Nils. During your presentation, we received a question from the audience. Can you tell me the biggest changes you've seen in the way we work over the past few decades?
Yeah, again, it's to understand the work cycle. That's the key element. That's where I believe that's where we need to start. We also need to understand how long time it will take before you need to charge the battery again. So system requirements is key to make a good and optimized system solution for you.
Thank you so much. We will see you later again. But before that, we are shifting gears a bit. What does it take to electrify a wheel loader? And what are the learnings from such a project? Join us as we delve into this fascinating case study with our panel of experts who were at the very forefront of this project. So Ari Vuoronen, I hand over to you and your panel.
Thank you, Pernilla. And warm welcome to our panelists, Henrik Luserius, Managing Director from CE Engineering Solutions, David Ginander, Key Account Manager from Parker Hannifin, and Erik Forsberg, Systems Engineering Manager, also from Parker Hannifin. So I would like to start from the background of this project. First of all, Henrik, could you actually explain the relation between Volvo and CE Engineering Solutions?
Yeah, very well. So CE Engineering Solutions is owned by Volvo. Has a history within Volvo for about 5 years now. And historically, we have done a lot of different machine type of modification to different type of application within the construction and mining area.
Right, good. And then about product itself or project itself? What type of product are we talking about, and or machine we are talking about, and what kind of let's say modification we had as a target?
Yeah, so why wheel loader?
For example.
Yes. No, so together with Volvo, looking at what opportunities are there. So we chose the popular mid-size wheel loader, in this case the L120. And the reason for modification also, the opportunity to come out quickly in the market with something and more complementary to the other internal developments. And we also then foresee that the circular economy can also help, for the future to be able to actually extend products' life by doing the conversions.
Yeah, anything? Yep.
And I think we can say that what we have done is really to take the standard machine and fitted it with a complete kit that is changing it over from a combustion engine to a fully battery electric machine. And we from Parker, we have designed the system to fit into this together with Volvo and CES, of course. And it's a kit that is replacing all the components that you need in the system, not only an electric motor, but of course batteries, of course chargers, and all the thermal management side. So it's a large kit that we use that CES is installing in the machine, in the Volvo machines.
Good. Maybe about the targets of the project. I understood it's been started like 2 years ago. What was the starting point? When to do and what and so forth?
No, so the main target, of course, was to convert the products, and time to market is critical in order to get more products out there and get good learnings from it. And as I said, the machine specification was decided together, and then it was really coming into the how part. How would we now go ahead and do this? And based on the different skill sets that we have, us being good at modifying machines, Parker having the electrification experience, and then Volvo knowing the product and performance very well, that was how it started, and decided what to do.
Good. David, when we were approached at Parker by Volvo and CES, how was the first reaction? Were we like ready for this, and what were the, let's say, how clear it was from the beginning? What is the way forward?
Yeah, I think from the beginning, I think when you get an opportunity like this from Volvo, the initial reaction was, wow, this will be super exciting, right? And it's also critical because I think the Volvo and the Parker strategy and visions going forward with sustainability and our goals are very much aligned. And projects like this is what we need to do to make that vision become reality. So first of all, very exciting. Second of all, Eric and the engineering team said that this is perfect for us. We have the engineering capability, and we have the products and the knowledge. So initial reactions, very, very positive. But then, of course, you need to be aware that the traditional way of doing business is that you are providing system support or engineering support to a customer, and you are delivering a product or a component. And in this case, it's a bit more complicated. So we also needed to discuss internally, do we have the other functions in place to deliver and design a system? It could be supply chain, it could be commercial, it could even be customer support, because there's differences in providing support and delivering a component rather than designing the full system and be responsible for the full system and also delivering the full system. So of course, very exciting, but also a bit new ground.
So Eric, how was the challenge taken in your engineering team?
It was, of course, a big challenge, but a very exciting one. I mean, we have a very long history with Volvo, both from previous electrification projects, but also within the hydraulic side, where we have been partners for many, many years. We also have a lot of experience in the team regarding electrification with other customers. So I think this was very exciting. I think it also suited really well with this partnership approach that we have, not the traditional way of working really maybe, but it's a very nice way where we from Parker, CES, and Volvo are working as partners and collaborating on finding the solution based on a very common target and goal, where we really focus on getting using the best of our expertise. So from Parker's point of view, we do the system design and the control systems. CES do the mechanical installation, where they're really skilled and really know what they're doing, and also the CE marking, which is something that you do on a regular basis, while Volvo contribute with their part with the machine expertise and know how the end product should operate. And also how we should interface with the machine when we design the system.
Good. So now we are more or less clear what were the, let's say, the responsibilities probably from the beginning of the project. How did the project get started? What were the first steps, and how did it feel in the beginning? Did it start moving forward?
Yeah, no, I would say this, that from beginning Volvo was seeking partners. And Parker being natural on this side. Then, of course, we are a Volvo company, but we were also part of a selection process also. We have some experience in the electrification field, but relatively new to battery electric. But then all combined seem to be the best setup to do. So then the starting point really, as we said, a very clear end goal, what should happen. Now looking back, it's not that long time ago, but we're very focused on the target, and would say also that the personal chemistry actually came out very well, because again, common target. We didn't spend much time in trying to really boil down to the nitty-gritty details at first, because there were learnings to be made before understanding how we best were developing things together.
Maybe taking contact or comment from that nitty-gritty details, that maybe pushes now us taking a step back. Often our, let's say, cooperation with bigger companies is fairly detailed, and there is contracts and so forth. David, how was the contract side and let's say getting to an agreement what to do? How was that handled in the beginning?
You're absolutely right there, Ari, that there is a contract in place between the two companies. But that's more focused on the traditional business that we do. And in this case, being able to meet the time to market demands, we sort of had to do a gentleman's agreement, trusting each other, because to do a proper contract between two big companies, it would have taken too long time. So I think all the three partners involved here took a sort of a risk, or at least a calculated risk, saying that we have a common target. I think we wrote something down that yeah, let's agree to this, but we had to go out on a limb a little bit and take a risk without the proper paperwork in place, let's say.
But as we said, we have a very long and good relationship today between the three, and I think from our point of view, it was not that much of a risk, to be honest. We know how we work and how we operate, so it wasn't that much of a risk, I think.
All right, good. Now we have three parties who are obviously have a common goal to meet the customer expectations, have a pleased customer. Where are we at the moment? How has the project progressed?
Yeah, so we said it's about 2 years ago, maybe starting point. We have had products out in the market testing for over 1 year, and we have end user products out as well now. So customers are happy with performance. Also, then we should say that the distributors and customers involved, they also understand that there's a lot of learnings to be made. So they do also see that iteration approach is what they want to see too. Otherwise, they would need to wait too long for the product. So all are happy to be part of the activity.
I think it's very interesting the feedback we get now from the customers that actually have the machines right now. Obviously, it's very quiet, no emissions. It's very nice to operate with the electric motor. It feels very, very strong to operate. Even though it's the same power, it feels stronger to operate, and the customers are very happy about the performance as the feedback we get. And I think working in this kind of partnership also allows us and the engineers from Parker in this case to actually have direct contact with the end customers, which is very exciting from our side as well.
Good. We have been now kind of laying the count that, okay, this has been very much a partnership and cooperation. Probably during the test there has been a little bit those moments also when everything is not sun and shiny. How have we handled those moments?
I would say, I mean, in a partnership that it is, there's been ups and downs, challenges to be overcome. But again, with a common goal and target, that has been the kind of guiding light through the storms that may have been had. But that again, you know, it's so much to learn. So that has kind of been the trigger point here also to continue.
Yeah, and there have been a lot of people involved.
Yeah.
But still there has been a very, let's say, short communication routes and no real hierarchies. And I think that's also key because, yeah, there will be bumps in the road. But we have been working together with them and not pointing fingers and say, hey, we need to do this together now. And everybody is involved all the time.
It has been based a lot on trust, I would say, from all sides. I think a good partnership, you will always have ups and downs, but you will always work them out, I think, with this common goal that we had.
Yeah. And, you know, a traditional way would be that you deliver a product, sometimes a system, and we would integrate it and then, you know, fronting the end user. But now to have very short communication channels also, if we have had some issue, which all products have, then rather than, you know, going through all the different steps to come back to the customer several days later, we typically go jointly and support the customer in the end.
So now based on this experience, is this then a model that will be used also in the future for other development projects?
If you ask me, I think so. I think my company being a smaller part of Volvo, but even overall, you know, partnership is seen as a good model forward because of you can utilize the best skills of everyone. So knowing this, the electrification journey is such vast. This is a must, you know, to be able to come forward in the speed that we want. Yes.
David, something from your side?
No, I would agree. This is the way forward. The speed to market is critical. Also from the technology side, the technology is not mature yet, so it will change fast. So it means that the machine that we deliver today to end customers will probably not look the same in 1.5 years. Normally a wheel loader look the same for 8 years. And then you have that component as well. So it needs to be iterations and closer relationships, otherwise you don't have time.
Mm-hmm.
Yeah, I think to be able to meet the big requirement from the market to really get the machines out in the market quick as required, we need to have these kind of partnership to be able to develop really fast. And I think also there's a lot of changes ongoing in the battery market, for example, which is going to require us to respond really fast and to go through these design iterations all over the time. We are going to have to work in this way, I think.
But all this sounds like a quite fundamental change on the, let's say, the business cycle. So work machines have been, let's say, relatively stable for many years, and now we are talking that we are following the market, how the technology evolving, and knowing that the technology is evolving quite fast. It sounds like that the rate of speed of changing things and the machine designs is accelerating quite a lot.
No, for sure. And again, you know, there are many parallel technologies, and you cannot really wait for the final one because you don't know what it is. So if you're not part of the progress, you're gonna lose a lot of knowledge on the way.
And we can't just sit and wait for batteries to be already developed. Then we're too late, I think.
Yeah. Do you see some customer segments or machine types or something where this kind of model will be especially used?
Yeah, I think, electrification in general is starting from some segments, but I would say that the application is quite wide already. Having said that, still kind of early in the journey, but I think the want is still bigger than the supply at the moment.
I guess you can also add there that we talk about the partnership between Volvo and Parker now on the supplier side. You also need, and we already do that, extend it to the customer side, right? You need trusted customers where you can try things out a little bit, right? So that's also key here. Don't forget that there is a segment of customers maybe that is more able to try things out and more suitable for that type of development project.
Sure. Now to add to that, as you said, there are both bigger and smaller companies. We talked about the Paris Agreement before. Now that is a widely supported approach, right? So I would say that it has gone from the early adopters, smaller volumes at least start to enter, let's say, the early maturity. But there is still a long way to go. Yeah.
Well, all this sounds very interesting. Will be interesting to see what are the next steps between this partnership. But at this point, thank you very much for all the panelists for excellent discussion. And over to Pernilla.
Thank you, Ari, and a special thank you to the panel that shared your perspective and your knowledge. Do you have a topic that you would like to discuss with our team? There is a QR code visible on the screen now, and if you scan it, you can connect with someone in our team. And it's with great pleasure that I introduce our next speaker, Tom Kühne, with 15 years of experience in the marine industry. And he has not only made waves, but also significantly advanced the field of mobile electrification. Tom's deep understanding of the marine industry, fueled by his passion for sustainable technology, positions him as an invaluable asset to our discussion today. So, Tom, I give the word to you.
Thank you very much. So, my name is Tom Kühne. I represent Stream Propulsion. We are a company that develops and produce electric outboards and complete powertrains, and also boats. And today I'm going to speak a little about our products, but also the market and the challenges we see on the market for electric boating. So you get an understanding for how the transformation will go. But let me start from another angle. This is a satellite Voyager. It was sent out in space in 1977, and it's gone interstellar. And on this satellite, there is a golden record with containing sounds, music, pictures from the Earth. And there's also a letter from the president during that time in the US, Jimmy Carter, and he wrote that if one such civilization intercepts Voyager and can understand these recorded contents, here is our message. This is a present from a small distant world, a token of our sounds, our science, our images, our music, our thoughts and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. Jimmy Carter, President of the United States. So, on this golden record, there were 116 pictures. So if you're going to explain our planet for someone that never been here, and you only have 116 pictures to show our species, our culture, architecture, art, whatever. So if you do that, and one of the pictures is on a boat, then my conclusion is that boats are very important. Having said that, let's go and look at what we have for our customers. Stream propulsion then. We develop, design, and sell complete electric powertrains. So it's all from batteries to the outboard engines from 15 up to 50 horsepower, that is today. We will go even further in the future. And we also make boats. In this case, it's rib boats. And more to this, we also do all the harness, communication systems, throttles, and chargers. And if we zoom in on one of these engines, this is a 50 horsepower engine, you can see the Parker parts that we are using. So it's the electric engine, it's the inverter, we are using the Bluetooth, we are using the control system, the ICANN system for this. So it's a complete, everything in the outboard is from Parker. If we look at the market that we are on, here is the market. So let me show you a little bit. This is the three big markets in the world. It is Canada, it is the US, and it's Europe. All in all, it's approximately over 20 million boats with outboard engines out there. And most boats, they live for a very long time. So to do a repowering of these boats, it's quite common. So this is the repowering potential we have when it comes to electric outboards, to replace the fossil outboards. And if we look in our home market, Europe, it is approximately 5 million engines. 5 million engines that could be replaced with electric outboards. Yearly, there are approximately 800,000 units fossil outboards made yearly to replace on these repowering boats, but also for new boats. If we look at the driving things for us when it comes to taking market shares, it is legislations. It could be legislations like the Fit for 55 in Europe, where there will be things happening in the future. It could be EBI, which are coming with their recommendations for boating. It could be CNCA, and that is cities around the world that has decided for a zero CO2 initiative, and in 2030 or 2035. And within that, there are also regional and local restrictions, for instance, in lakes or channels, that are very important when it comes to the transformation from fossil to electric. We have the UN working with these things too. And last of all, in this case, it's the CARB, Californian legislations, where they 2031 will not have fossil engines under 19 kilowatts. Well, what are the challenges then when to sell electric boats? And this is for all companies that are making electric boats. Well, there are three things that are obvious. First of all, it's a higher upfront cost because of the batteries compared to a traditional boat. So it's important for us to show the long-term savings they can do in this when it comes to fuel costs, when it comes to service and maintenance. And it's also a question on what kind of financial system we have around the batteries. It could be renting or leasing or something like that. Second, it's the charging infrastructure. And here we are promoting companies that are doing these things, putting up fast chargers. We also try to have systems that enable us to use the systems, the infrastructure that's already there. So for our 15, 30, 50 horsepower engines, they can use 230 volts to charge it, 6, 10 or 16 amps. So in almost every harbor, at least the big harbors, you have these facilities. And thirdly, it's a question of the customer's perception and awareness. So to make them aware is a question of marketing, but it's also a question of education, and not education in a bench and with a teacher. I'm talking about education from your neighbor, or your friend, the family, your children, that can give you other thoughts about what kind of boat you should have. Our strategy then, overall strategy, is to targeting the key customer segments and building strong partnerships, and then thirdly, offering competitive pricing, performance and high quality with local sales and support. So if we start with targeting the customer segments, we see 3 different areas. And these areas are recreational and transport consumers. And many of them use their boats a lot for transportation or during the summer. And for them, it's economical benefits to go electric. The second group is the eco-conscious consumers. They prioritize sustainable options. So electric is natural for them. In many cases, they have an electric car also. And thirdly, we have the commercial operators, and that is could be companies that work with tourism, but it could also be companies that work with transportation or sailing schools, coach boats, and so forth. The second thing that we talked about was building strong partnership relationship. And here we have some suppliers and partners. And these are the most important one when it comes to the outboard engine. It is Parker. It is that are providing electric motors, inverters, and control system for us. It is Stabe that are closely connected to Parker. They sell their products. They are helping us with development and assembly. And then for the mechanical parts, it's Tohatsu. So these 3 together are very important for us to make the outboard engine. Last, then, we talked about sales and support. And today we are in the Scandinavian market. We are in Italy, Spain, Portugal, Hungary, Belgium, Netherlands. And we will cover this map totally within the next years. So it will be orange, everything of it. Because we think it's very important to have these sales support when it comes to electric powertrains. As a last thing, I would like to show you a movie, a small movie with a test boat that a company called Riemann Limited are launching this summer. So this is the first test they've done with it, just to show you how it works with electric drive. There is nothing wrong with your computers when you look at these movies if you don't hear sound from the engine. It is that quiet. So you hear it in the beginning, but then it fades off. So please look at it and say what you think.
Är ni redo? Vi säger att ni är redo. Håller ni, då får du sätta ner. De säger att det går fruktansvärt fort. Nu kör vi! Ja, det är framförallt ljudlöst. Det är härligt. Underbart. Jag har ju kört de här båtarna i en liknande form för länge sedan. Det här är härligt. Håller du dig, Filip? Nu kör vi lite här. Det är första fartbåten på mässan ju. Man känner att den har otroligt mjukt gångläge. Alltså det är väldigt stabil och väldigt mjuk hantering av de vågorna som kommer.
Vi har
Ja, intressant.
lite dåligt ljud på dig,
Ja,
Gustav.
men man hör att han är entusiastisk i alla fall.
Ja, verkligen. Men du, jag bara tänker så, när man ser de här drönarbilderna också, så det här med att flytta vatten. När han kör, hur fort kör han nu då? Han kör i 25 knop kanske?
Ja, det gör han nog minst, ja.
Ja, men det ser ju ut att vara ett ganska bra skrov där.
Framförallt så ser du ju att det är inte mycket vågor.
Nej.
Det som du flyttar på när du planar, det är ju den energiåtgången som båten gör. Och här har du inte mycket vågor.
Nej.
Den är energieffektiv.
Thank you so much, Tom. And for those that don't know Swedish, this boat was running in at least 25 knots, and soundless. Yeah, so quite impressive. Tom, how would you describe your partnership with Parker?
Our partnership, it's very important. First of all, the components and the quality of components, but also the knowledge around your components. It's crucial for us. And together with Staub, but that's also connected to Parker because they are selling Parker products. It's vital to have these. And then they help us with everything we need when it comes to the technical parts. And if you were going to speed up the time to market, this was the way to do it.
Great. Thank you for hearing your testimonial.
Thank you.
Are we ready to embrace the full potential of mobile electrification? And what challenges do we face as we move towards a more electrified future? Ari Vuoronen will once more lead a panel who will discuss the future challenges in mobile electrification. Ari, I hand over to you and the panel.
Thank you, Pernilla. Before jumping into the panel discussion, let's actually take our first or second poll question. And this time we want to hear from you. Do you have a trusted partner to liaise within your electrification journey? 3 alternatives for the answer. Yes, we have. Or we are looking for a partner. Or no, we don't need a partner. And we will look into the answers later on. But please submit your answer now while we are actually ready to start the second panel discussion. So first of all, warm welcome to the panelist, Ville Eskelinen, CEO of Hevtech company, Nils Henriksson, manager of the MCE here at Parker Hannifin, Ari Puranen, application engineering manager at Parker Hannifin as well, and Tom Köhne, co-owner of the Stream Propulsion, and you just gave your excellent presentation about your company and products. So let's start this discussion from the markets. Are the customers, machine builders ready for electrification? Tom, you just gave a really excellent presentation on Stream Propulsion. How do you see the market readiness and how do you see the progress of the market?
Yeah, I think it will take time because we're a little bit behind the automotive industry. So, but we are coming there. So, for instance, we see that if I compare fairs now compared to 4 or 5 years ago, for instance, there was a fair now in Holland, in the Netherlands, big boat fair. 50% of the boats has had as an option to go electric.
That sounds quite almost like revolutionary compared to what the situation has been just a few years ago.
Yeah. So,
all right, very interesting.
And the driving force in this will be the legislations that are coming. We see it now in lakes and we see it in channels and it's coming more and more. So there is no option. So electric is the only way forward.
Okay, that sounds pretty convincing on that side. Ville, how about you work a lot with different kinds of OEM customers and actually the end market as well. How do you see the situation?
Well, it's quite divided. So we can take kind of rough examples from the far edges. We have underground mining, for example. And there they have already had multiple tens of years of electrification because the driver is getting heat and getting combustions out of the mine itself. So one of the key features or key costs of underground mine is the ventilation system. So if you get the fumes out of there, it really helps, and there's already a healthy business case without promoting it in any other way. Then if we just kind of jump to the other end of it and go to really remote locations where you don't have energy, there the situation is completely different. So the angle is more hybridization. We have an IC motor and then engine, and then we pair it up with batteries or supercapacitors or so on. And this could be, for example, forestry equipment. And there the challenge to be solved is completely different than in the underground mining. And then we can consider, for example, these urban work sites where you have smaller and medium-sized mobile machinery, and then that market is growing at the moment. But like it's said many times today, it's something that is developing at the moment.
Okay, great. Niels, how about from a system supplier perspective? How do you see it?
Yeah, I think you're spot on. I mean, to understand what is the problem we try to solve. So if we know what the machine get used, what is the challenges, and why are they looking in for electrification, is a key element. It's not one solution fit them all. It's to understanding why and what is the problem we'd like to solve by electrification.
Yeah. Ari, how about you, from your perspective? For example, I know that you are working also on the on-road side. How do you see from it?
Well, it's legislation and the local regulations, like all over the Europe now, green zones in the city centers. They are driving certain businesses towards electrification. Refuse trucks are the front runners right now. Construction machinery, if they want to operate in the city centers, they have to follow also municipal vehicles. Streets need to be cleaned, so it's kind of a mandatory in the future that at least some part of the fleet is electrified.
Good. Any other examples where of markets where the lifetime cost is actually beneficial for the electrification? Underground mining is the typical example, but and often used. But do you see other markets where that can happen in near future?
Material handling and also what Ari just said, especially the construction in the urban environment, it's probably the main driver. So yeah, I would say the whole mobile market, off-road, on-road, everyone is there. Still, different challenges, different problems to solve.
Talking about the challenges, what are the technical challenges you see, Ville? If you look at from your perspective, what is the kind of where do you start and how do you progress on this kind of development projects?
Well, we start from what's been brought up today many times, is the work cycle. First of all, you need to understand what is the machine function. Where is it operating? What kind of ambient temperature is it around? What kind of possibilities do you have to charge the vehicle? And from there on, you need to move on to think about what is the best solution for each machine. So from our perspective, for example, this material handling, this is interesting. This is something that we did with the Norwegian importer of Hitachi machinery. We have a 16-ton excavator there that is with a small battery pack, roughly 40 kilowatt hours, and it's connected to the grid most of the time. So basically that enables 24/7 operation for the machine and still maintaining a little better cost angle in building such a machine. The other example is that we built a electric pile driving rig with a Finnish manufacturer called Juntan, and typically what we found out in the beginning of the studies is that you might have 63 amps, 400 volts at the work site, and you need to manage with that, and you have a 64-ton rig. and 250, 260 kilowatts of power going in there. So the math is quite simple that you either need a huge battery pack or you need to figure out something else. So we decided that a swappable battery system is the correct solution. And then again, going towards this kind of remote locations where there is absolutely no electricity available. There we had a solution that we have an ICE and supercapacitors. And with that solution, it's high power all the time. We cut down 1/3 of the consumption of the machine and also increase the productivity. So there's all these different things that you need to consider when doing this.
Stretching this a little bit to different angle, Niels, how about digitalization and autonomous machines? How do they link to the electrification journey?
I would say, especially if we talked about digitalization from a control standpoint, I mean, you can't make any electrified machines without a decent control system in place. Of course, you have all the control algorithms, what you need to have pretty well mapped out what you would like to achieve with your electrification. But of course, also having a big portions of functional safety, going really hand in hand about what you need to achieve with your control system.
Good. Ari, thermal management has been mentioned actually in the previous presentations, and we had actually 2 breakout sessions as well around that. How do you see the thermal management? How big of an issue is that on electrification?
Well, it could be the most difficult thing if your system design is not correct. We have learned a lot on the way. Also, our customers have learned all the way. But if we go back like 10 years ago, it was pretty much ignored in the beginning, and then it kind of generated a lot of hurdles. So now people are aware that you have to take the thermal management into consideration, but still it is a challenge.
All right, good. Tom, how about from your perspective, what kind of technical challenges maybe have been, let's say, the most challenging, or what is your insight for this?
I think it's the thermal management we talked about here before, because we are squeezing out maximum what we can get from the engines, and being on the sea is like if you drive a car and compare it, it's like driving uphill all the time. So it never rests. So we need to cool things down. It's very important for us. And there, Parker has been very helpful with that. And that's one of the main reasons why we chose the engines we did, because it's excellent when it comes to thermal management.
I would like to add, according to thermal management, it's don't wait to the end of the project. Keep the thermal management as a part of everything else, because it's so important for a complete system package.
Okay. I hope everybody heard that now. So the message is clear. Anything? Yeah.
It's a complicated system. So you have this traditional system of if you have work hydraulics, this is something that you need to handle. But then you have all these different elements in the electric driveline. So you have, for example, your batteries, and then you have your power electronics and your electric motor. And the batteries and all of these other components, they do not share the same window of good operation for thermal. In terms of thermal range. So you need to really keep these separated, and it automatically makes it a complicated system because there are so many different items involved in that system. But in addition to that, then thermal management is not only cooling the system, it's also heating the system. We're in the Nordics. We need to heat our batteries to be able to operate them during the winter time. We need to heat up the cabin, possibly make it a better operational area for the operator if there is such, and no automation involved. But then again, we turn that around. We go down south. We have hotter countries. Then you need to start looking at active cooling and actively keeping the thermals in control.
Exactly. I think we have now listed first of all that let's say the market is ready or getting even more ready, and there are high expectations. We have also covered a little bit that, okay, there are key technical areas which really need to be covered and taken care of. Doesn't sound like a very easy task. Tom, how about the resources, knowledge, all that? How did you manage that in your case?
Yeah, we're a small company, so we rely on our partners. And in this case, it's Parker and Stabe that's been we've been working together with.
Yeah,
and that's the only way to go forward for us. That's the way to do. And that's the way we work. So when we develop, for instance, the next generation of outboards, we will do that in an ad hoc group together with Parker and together with Stabe. We will run that project, and then when we have solved everything and it works, then we go back to normal again. So it's perfect for us. For us, it's normal to get help from in this case, Parker and Stabe.
Any perspectives on this, let's say, finding the right knowledge and having the, let's say, right resources around the project or in the project?
Well, from our angle, it seems that the help is well needed in many cases. Traditionally, manufacturers or OEMs are capable of designing their own systems in-house, and they have been accustomed to do it, at least the bigger ones. The medium size and the smaller size might have already been earlier kind of adapting the integrator or the help outside, and I think this is something that the larger OEMs are now also understanding, because the electrification is in a way completely new. There aren't really that many people around who actually have deep competence in electrification. So they do need to find these partners that can help them manage their projects and products also. But for the medium and small size, they are heavily dependent on integrators and help on electrification.
I think the first panel discussion was very much around the, let's say, the partnership and trust and so forth. And over there we already touched a little bit that it is not only the knowledge of the engineering people, but it is also knowledge more broadly actually throughout the, let's say, the whole chain of departments and activities in the company. Niels, anything you want to add on that topic?
Yeah, can just echo what you just said. I mean, electromechanical knowledge, control knowledge is of course the key base. But we should not forget that these batteries, what we have here, they are dangerous when the voltage going up. So we have service personnel what actually are used to working with this type of equipment in the future. Should not be forgotten. It's equally important for the future as well.
Yes. Okay.
And then, of course, when you ship the machine out, you need to give it the service, but you need to also train the drivers, because, as mentioned before, digitalization is coming. So some of the conventional machines which been relying on hand levers maybe, or PC controls, now you have the electronics there, the machine behavior is different. Marketing people and salespeople, it's a totally new business model. So in some cases you don't sell the machines, you lease the machines. So it's the whole food chain, if you can use that term, actually needs to be trained with these machines to understand what it's all about and where the value is.
Yeah, I mean, at this point, everybody is gaining knowledge on what they are building on. And for example, in a project with us, typically the first people to learn about electrification is obviously the engineers that are involved on the OEM side. So they have their mechanical team, they have their hydraulics team, electrical team. Everybody will get this kind of jump into the electrification, but then also it's quite typical to arrange a day or two this kind of technical service personnel teaching so that they understand what kind of system they have, what are the dangers. You know, it's like mentioned, it's high voltages, and you need to make sure that you measure twice and be sure not to get electrocuted, and you have proper procedures on how to de-electrify a machine when before you start actually working on it. But then continuing from there, you also need to have sales and marketing that actually understand what they are selling. So it's another point that this electrification needs to go through the whole organization. It's not only the technical people involved.
Very good. Now we covered quite many aspects, and maybe then the final question is that, so the future, is it like bright or is it gloomy, or how do you see it? Are we here to win with the electrification, or how does it look for the years to come? Maybe starting from you, Ville.
Electrification, hybridization, everything that is in between. I'm seeing it going that way already. If you can't electrify completely as a battery electric solution, then you can find a hybrid solution, bring in alternative fuels on top of that, and then lower the emissions.
I agree totally. I think it will not purely be electric everything. It will be a mix of things. So, but I think definitely it will. If you take for the marine business, I think it will be quite big, the electric solutions.
But also all the components what are ready today. I mean, if we go back 10 years, we were just new about it. Today we have dedicated product for the dedicated mobile market, and we are there. And still we can just continue to see it will be small features, what will be added to be more optimized into the market. So yeah, it's definitely there.
All right. To me, it sounds like that we are ready to take the challenge. Thank you very much for this discussion. And then I'm sending this over to Pernilla.
Thank you so much, and I would like to express my sincere gratitude to the panel. I think the future, for sure, it looks very promising and interesting. Before the discussion, Ari asked you if you had a trusted partner to liaise with in your electrification journey, and now we have the answers. So we can see that 60% of the audience already have a trusted partner, 27 are looking for one, and 13 they don't need a partner. Ari, what are your comments on that?
Well, it looks like that there is probably a good or fair share of our customer base already watching this event. But obviously, almost a third still looking actually for a partner. And I think on the not needing the partner, I think there are, for example, universities where, yes, they don't maybe build the machines, but we are definitely working closely with them as well.
Yeah. And if you are among those who's looking for a partner, you can scan the QR code that now is visible on the screen and get in touch with one of our experts. And also, I would like to say, since we are about to summarize the day, there are a couple of questions that you submitted and that we weren't able to answer. We will reach out to you separately. So, Ari, would you like to summarize the event?
Yes, thank you very much, Pernilla. We definitely got many new insights during the day, and I would like to highlight maybe 3 areas. First of all, we had a very good presentations on the technical side, both from the component and system understanding. Secondly, we got very eye-opening information about the markets, excellent customer testimonial and so forth. So we have the market growing and it's moving to the direction of electrification. So then we go to the third point, which last but not least is actually how to make it happen, where are the resources, how to get the knowledge, and how important it is actually to make cooperation and create partnerships. So with this, I would like to thank the presenters, the panelists, the audience who has been following us during this afternoon. It has been a great day together. We have demonstrated how Parker can help you on your electrification journey, and please reach out to us, and our experts will be available to you. One excellent opportunity to continue the discussion will be actually in the end of August when we are joining Finmetco exhibition in Finland, where we will be presenting and showing many of the technologies that we discussed today. So let's continue to talk electrification.
Thank you, Ari. So, and again, if you couldn't attend the full stream or want to watch additional breakout sessions, the recordings will be sent out shortly. And when I still have your attention, I would like to ask for a small favor. Later today, you will receive an email with a survey, and we would be happy if you could fill that in. It will take just a few minutes of your time, and the feedback that you provide is very valuable for us when we plan for the next event. Finally, a big thank you from me and from the team for your attention and attending today. And until next time, bye-bye.
Electrification has a key role to play in our carbon-free future and 2023 objectives, and no one understands more about its diverse possibilities than Parker. Our cross-technology capabilities enable us to connect every part of the electric ecosystem, preparing our partners for the challenges of low-emission cities. In this last decade, we've been harnessing the possibilities of electrification in sectors as diverse as mining and agriculture, construction and material handling, transitioning on and off-road vehicles to the potential of electric and reducing emissions and TCO, whilst boosting power and control. From battery material technologies and electric motors to smart motion control applications, our solutions are designed to be part of a connected ecosystem, ensuring asset integrity and safety whilst increasing productivity and efficiency. A global footprint, combined with over 100 years of engineering expertise, help us to understand and anticipate our customer challenges, enabling faster time to market and ensuring commercial success. Ready to embrace the cleaner, smarter potential of electrification? Let Parker empower your electric future.